Hello! With the 3.06 release of KAS IDE software and PDMM and PCMM firmware, we now have stepper control built in through the use of our AKT2G Slice.io system. We offer two separate slices, the AKT2G SM L50 and L15, and these relate to the current output that they provide for stepper motors. The L50 can provide a 5 amp output that can boost up to 6.5 amp with an optional fan, and the L15 can do 1.5 amp up to 3 amp with a fan. Both of them support an optional encoder, and if you do not use the encoder, that's fine. The KAS system will just report back command position when you do not have an encoder, and even with an encoder, the stepper motors are still run open loop. When connected to an AK2G EtherCAT coupler, the SM or stepper motor slices can be scanned and they will automatically be found just like any other EtherCAT Kollmorgen component, such as our AKD, AKD2G, or any of the Slice.io products that we have, and then you will be able to find them in the EtherCAT Project Explorer section of the KAS IDE software. You can double click on the slice and you can set it up through a configuration screen. It contains a number of the Kollmorgen stepper motors in a drop-down that you can just choose, and it'll automatically import all of the motor information, such as the steps per revolution and the rated or reduced current for it. You could also optionally fill these in manually yourself, and then if you plan on reusing that motor that maybe not is in the built-in motor files that we have, either it was a custom motor or it was a non-Kollmorgen motor, you could always save that file and import it later in a different project or for a separate access. You also have the option of running it without encoder, with an encoder. Either way, the motor itself will be run open loop, but when you have an encoder, the function blocks to read position will actually read off the encoder. If you select no encoder, then it will just feedback the command position to the actual position function blocks. Also, I'm running it here off 24 volts, but it does go up to 48 or 50 volts to get better performance out of the stepper drive. Once you have everything filled out here, you also can go to the I/O tab to set up the stepper SM slice. It does include two inputs that you can use just as generic digital inputs, or you can optionally change the function and have it be a limit for the stepper motor to have it, if that input is engaged, that the motor would stop moving in that direction. And then once you have everything set up, you'll note that there are, just like AKD drives or S700, there's a drop down where you can map the SM slices to an axis. In this case, I'm mapping axis 2 to a stepper motor slice, and axis 1 in the project to the AKD that's a part of my PDMM controller. Compile and download my project. Then I will start it and go to the control panel. And this is just part of our 2-axis template project. And once the EtherCAT network light goes on, I know that everything's up and running and communicating with each other. And I can show you that I can enable, and both axes, both servo and stepper, are enabled. I can reset the position reported by the encoder to 0, and now when I do a absolute or relative move of 90 degrees, my stepper motor does move almost to 90 degrees. I can hit back to absolute move to 0. It goes to 0. I can jog. I can also turn on gear and camming, and that axis can be either the master, in this case it's a slave, in a geared move, with the servo being the master and the stepper being the slave. So how do we program this? And once again, this is just the standard 2-axis template. The stepper axes use the exact same function blocks that have already existed for our servo motor control. So it uses MC power to enable and disable. It can be a master or a slave for an MC gear in command. It uses the same velocity command, halt if you want to decelerate to 0, on and on and on. Even the same function blocks to read information, such as MC read actual position. And once again, I said if it's have an encoder, then it will read the position from the encoder. If you don't, it will just read the command position to this stepper motor. So it uses the exact same function blocks, whether you're in PLC Open or Pipe Network, that you would use for a servo motor. The lone exception is there is no position latching engine like we have in the AKT drive, so the touch probe function doesn't work. But pretty much all the other motion function blocks and function blocks to read information, clear faults, enable disable will work. Also with the 3.06 release, we've updated the built-in fault reporting. So now you can use the exact same function block to read faults off of AKD, AKT2G, and the AKT2G Stepper drives. So when you're starting with the built-in template, no matter what axis you have, the function block will already detect what drive you have. So it will not only tell you if Boolean true, false, yes there is a fault or not, but it'll also tell you the number and a string-based description. Once again, regardless of what type of axis connected up to that function block. And also, I do not have the L15 slice connected, but it is set up very similarly, almost identical to the higher current version, the L50. And lastly, you do have the option of setting it up to this configure via COE init commands. All that will do is, instead of filling out all the parameters for the drive and the motor through these nice drop-down menus and the I/O screen, you would just do it yourself manually through a COE init commands. These are the default, all the ones that are done automatically filled in when you use the configuration screen. So that's it. It's very easy to use the new AKT2G SM or stepper motor modules to integrate stepper motor control over EtherCAT with a KAS controller.